Okay, so we're on 6.1, basic identities. Hey folks, how you doing tonight? And I just finished up doing the Pythagorean identities and connected that with the unit circle. X squared plus y squared is equal to r squared. And tomorrow in class, we will then derive the other two and see how you get from cosine squared plus sine squared equals 1. Some of you probably have some ideas already to get equation number 2, and 3. So we're working on now the cofunction identities, and you may have learned these in geometry when you were dealing with triangles, but the sine theta is equal to cosine pi over 2 minus theta, and the tangent is equal to the cotangent of pi over 2 minus theta. And the secant is equal to the cosecant of pi over 2 minus theta. So you can kind of see this relationship going on. And I think it's very helpful to say, well, what's going on here? And how can I get a more concrete way of looking at this? So if you look down below where I have this triangle, you can see that we have 90 degrees. And the sum of the other two angles in the triangle must equal 90 degrees, right? Because there's 180 degrees. So what we're going to do now is we're going to put the regular the ratios on the side of this, where I have 30 degrees, 1, 2, and root 3. And as I said, these you really want to get familiar with. The simplest basic ratio of a 30, 60, 90 triangle, right? So now, if you notice, if I take cosine A, I did have a B on the side, like here's B, here's B, here is lowercase a would be 1, and then of course lowercase c would be 2. So you can see my formulas down here that cosine A, is B over C, and sine B is equal to B over C as well, right? Well, if I write this the way the identity is written above, sine theta is equal to cosine pi over 2 minus theta. So we'll start with the sine theta. So how about if I say sine, how do I want to do this? Sine of, we'll say 60 degrees. And so if you look at sine of 60 degrees, you're going, okay, then that's going to be, sine of 60 is root 3 over the hypotenuse. Oh, just wrote it 2. Root 3 over 2. And then the cosine, notice that the cosine of 30 degrees, the adjacent over the hypotenuse, is also root 3 over 2, right? So they are equal. So now if I would have to write this down the way the identity is written above, sine theta, I'll take 60 degrees. So now I'm not using radians, I'm in degrees here. So the sine of 60 degrees, notice, is equal to the cosine of 90 minus 60 degrees. So when considering that angle theta being 60 degrees, then cosine of 90 minus 60 would be equivalent to it. That's all these are saying, that within your cofunctions, you have this relationship that exists, okay? So we're going to use that. The other thing is the even-odd identities, and sometimes they're a little bit harder to identify apart from the graphs, but once you realize what the functions actually look like, you know what odd and even functions are, and we'll investigate that more tomorrow as well. So here we go. We're going to start off. We're going to start with the first one. It says, use the cofunction and even-odd identities to find each value. We're looking for, in the end, the cosine of pi over 2 minus theta. But we're given that sine negative theta is equal to negative 0.97. So you can see that the first step that I take is I take the relationship with the red star, sine theta, negative theta, is equal to negative sine theta. So that is true. So what we're going to do is we're going to take that, and then I'm going to simplify that. I'm going to say, wait a second. I have sine theta then is equal to 0.97, right? So now what I can do is I can say, well, if that's equal to 0.97, then using the identity, then the cosine of pi over 2 minus theta is equal to sine of theta. Maybe I want to put that backwards. I'll put it right just like the identity over here. Sine theta is equal to the cosine of that. So the cosine of pi over 2 minus theta is equal to then 0.97. And there you have your first answer. Okay, up a little bit. All right, so there's the first problem. Now, I know most of the time I like to say is equal to 0.97, but I'll leave it like that. So now tangent is also an odd function. You see I have it blue starred up there. I'm going to switch over to the blue pen. So with that, the first step is that you've got negative tangent alpha. So that little fish looking thing is alpha. Put a little I in. Needs a fin, but So then knowing that, then we could say that tan alpha then is equal to the positive 2.36, right? So now that I have that and I'm looking for cotangent, then I can use that identity where I'm going to say that tan alpha is equal to the cotangent of pi over 2 minus alpha. Right. Now, that's not what we're looking for, is it? We're looking for the opposite expression in there. But so let's see if we can stick with this as much as we can. So now I know those two are equal, and I know that cotangent of pi over 2 minus alpha, they would be equal. Not what I'm looking for. So what I'm going to do is I'm going to say, all right, well, let's change things around here. Let's factor out a negative here from this. But so we want the cotangent of this one, right? So I'm going to go ahead and get that expression. I'm going to say the cotangent of negative of alpha minus pi over 2. Okay, like that. Because that's the same expression, right? We know that that is equal. They're equal, right? All I did was factor out the inside, right? That's equal to 2.36, right? So now, since now we have this odd relationship, cotangent, now I'm using this one down here, cotangent of a negative angle. And we got to figure in the formula above, it has just negative theta, right? But I actually have a negative pink shaded region there. That's my angle. So what I can do is I can use that identity and I can say, well, then that's equal to the following. It's equal to the negative of cotangent of alpha minus pi over 2. And so then that is equal to 2.36. So the cotangent of alpha minus pi over 2 is then equal to negative 2.36. And there's your answer right there. Okay, so I hope that was helpful. We had to reverse things there with our final answer, okay? And let me see if I can make some more room and fit it all in there. Okay, and then the last one, we're looking at the secant of beta. So that B is also a Greek letter. The B is the beta, which you can kind of guess. You guessed it right. Alpha is the first letter in the Greek alphabet, and beta is, dun, 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 second. All right, so we have the secant of beta minus pi over 2 is equal to negative 3.62. So what we're going to do first is we're going to say, okay, I have the beta first, and that's kind of like the last one, right? So I have cotangent alpha minus pi over 2. This is beta minus pi over 2. So my first step is that I try to make it look as much like the identity that I see. Now, you're saying, oh, well, where is it? Do you see right up here where you have the cosecant is equal to? I want to find the cosecant of negative beta, right? So my first step is I'm going to take a look at this and say, all right, I need this. I need the secant of the opposite of beta. Well, what I'm going to do is factor out a negative 1 here. So then I'm going to have the pi over 2 minus beta. Because all I'm doing with this is I'm factoring out the negative 1 factor. Okay? So you know what that is. That's the same thing. I haven't changed any value. It's negative 3.62. Okay, now what I'm going to do is I'm going to say, okay, well, what do I know about the secant function? So if we go up and look at the secant function, you can see that the secant is an even function. Okay, the secant is an even function. When we have secant of a negative angle, it's equal to the same thing as the secant of the angle. So guess what I can do? I can say, all right, secant of pi over 2 minus beta is then equal to negative 3.62. So now I have that, okay? Now, I want to find the cosecant of negative beta, right? The cosecant of negative beta. So when I look up at the cosecant of theta, negative theta up top, I see that it's equal to negative cosecant of theta. So that means that this cosecant is an odd function, okay? Cosecant is an odd function. So when I come down here, then I'm going to think to myself, all right, what do I know so far? I know that the secant is equal to, the secant of pi over 2 minus beta is equal to negative 3.62, right? So how is that related to, I know that the secant of, the cosecant of beta, because these are cofunctions, if I set this up, then this should equal negative 3.62. Again, because you're using, and let's go back up here. So you see the cosecant. Now I've got my formula set up here. The cosecant theta, or the angle, is equal to the secant of pi over 2 minus theta. So you must have the right form, and you do. So let me go back here a second. I think I might have said that too quickly. The cosecant is equal to the secant of pi over 2 minus beta. So you really try to match the form of the identity as you see above. Okay, you've got to match the form of the identity to say that they are equal. And you don't want the beta or the variable to be in front of the pi over 2. Okay, so we have, since this is equal to, secant is equal to negative 3.62, then we can say the cosecant of beta is equal to negative 3.62. And then our final statement is that, well, look above. It's an odd function, so really I can say that the cosecant of beta is equal to, because it's an odd function, the cosecant of beta is equal to the negative, well, if I say, let's do it like this. If I take the negative of cosecant beta, that's equal to positive 3.62, right? So then I know now that that's equal to negative cosecant beta is equal to cosecant, and I look at what I want to find, is equal to cosecant of negative beta. So that's your odd relationship that you have up top there. And so your answer is cosecant negative beta, as you want, is equal to 3.62. So you've got to build a logic chain, when you're thinking what is equal to what. And you can see how I went from the secant, and I went from the secant to the cosecant using the cofunction, and then I'm using the even-odd relationship between cosecant and negative cosecant, or negative cosecant beta and cosecant of negative beta. So we would finish this up with cosecant of negative beta, put that in parentheses, is then equal to 3.62. Now, this will take some doing and some focus that you'll work, they'll become like puzzles. How do you're really essentially proving that the cofunction, even odd identities, help you to manipulate your expressions to get or to prove that what cosecant negative beta is, what cotangent of alpha minus pi over 2 is equal to. Okay, so that's it for this section. Now, if you notice, you have some homework in this section, and there are a couple of things. What you're going to do is follow the instructions, though. There are different ways to do things, but we're going to use the quotient and reciprocal identities in the first part, and then you're going to use the Pythagorean identities to find each function value. So you're going to use one of those. If you have sine, you want to find sine theta, then you're going to use, of course, the sine squared plus cosine squared is equal to 1. And then if you want to find tangent theta, you're probably going to use, well, it depends on the information that you're given, because you're given cosine theta. So you may decide on the homework to say, all right, well, with the information that I have in question number 5, I'll take that and I'll say if the cosine theta is equal to negative 3/4, I'll say the secant theta is negative 4/3 and use the Pythagorean identity for that as well to find the tangent. So you end the same with 6. So why don't you, for homework tonight, why don't you do just 1 through 6? Okay, just 1 through 6, okay? Give those a shot, okay? And I'll see you tomorrow. Have a great day.